Hello everyone, myself Vinod Kumar Reddy Hepatam. Today I'm going to talk about introduction to Delta Lake. So we all know in the Spark world we do use Parquet, Avro, and some other formats, but ORC and Delta Lake. So there are a lot of formats that is being used, but none of them provides acid properties. None of them provides schema enforcement and evolution, and none of them provides us to do the things. All of them are immutable, and it won't be helpful for us for if at all if we want to do insert and updates. So for that reason they have like Linux Foundation has introduced a format called Delta Lake. It works on a change data capture way. We'll understand it a bit about it later, but in the Delta Lake, if someone wants to store the data in the data lake and they want to perform all the SQL operation like insert, update, delete, merge, and all these that can be performed using a format called Delta Lake. So now let's go through this Databricks book and understand each of them. So first thing is the data in the Delta format. In the background, the data will be stored in the Parquet format, but we'll have a log called delta log. So we'll understand about the delta log in a while. I will show that while I walk through the notebook. And it supports the ACID data integrity properties, ACID transactions and all. Schema enforcement and evolution. Schema enforcement is you can predefine the schema, predefine the structure of the table, and you can merge the schema if there is a change in the source format. That's what is evolution means. Audit history is, as I told you, the data is stored every time whenever you are writing, it will be writing to a newer version, and the reading that you are trying to do will be to the older version. That's where you are doing the audit history and the time travel. Delete and upserts is absolutely supported here, which actually helps everyone using the Spark SQL in the Delta Lake. And scalable metadata management this is highly scalable, and it handles millions of files and billions of rows, and it also supports both batch and streaming sources on sync. So let's walk through, right? So I I am taking a simple example in the case of Delta. Let's take emp.csv. I'm gonna read the data, okay, and I'm gonna display the data. First thing we need to create a Spark cluster over here, and please attach the Spark cluster and um, to make it work. So here is what it is gonna display. This is a table. So I want to see what is actually available in this location. Okay. These are the tables that I have created, and all of them is available in this location right now. And let's say I have now read the data and I'm going to store the data. Okay. Okay, if I wanna save it as table, then I don't need to do the full path. Okay. It's not empty, but it is not a delta table. So let me remove the things that is available in the warehouse already. So once I remove, then it will be easy for me to save the data. Okay. Now I will try to store the data. Okay. So now we have the data. Now if I check the location, if I list the data over here and check the location, it will show what is available for EMP delta. In this location, if I go, I will see a delta log. Let's try to read this delta log. So delta log is where all the things, the version, data and everything is stored. So let's try to read this. Warehouse EMP delta on delta. Okay. And if I try to read the data, this delta log. This is the delta log. I will walk you through what is this delta log mean. So that's the reason I'm trying to read the file as a text. So let's see. So in the delta log, it will show us what is the minimum version of the file that we are going to read. What is the minimum version of the file that I am going to write? Since the minimum version is 1, so you are going to, whenever somebody is trying to read, you will be reading the version 1. Whenever somebody is writing, it will be writing to version 2. Okay, this is the metadata. What is the type of table format, type of each column, and everything is, I think it has taken a string and it is mentioned as for employee number, it is taken as integer, for others it is taken as string, and also it is allowing the null. And here, if you could see, here it shows for each for employee number, what is the minimum employee number. These are the stats that is stored in a partition file in the Parquet. And here is also another stat, actually the commit info, wherein how the data is stored in the delta table. Okay, now with this, so this is how the data will be stored. This is how the log is maintained. Whenever you are trying to, let's say when I try to update now, okay, when I try to update the data, okay, here, when I try to update the data, you see, normally Parquet files are immutable, but the delta format is mutable and it allows us to update. So now, if I try to check the history of the file, it will show the history. What is the 0th version? It is a create table, and what we have done, that's the update. Okay, if you could see what we are trying to do, we are trying to update null values to 0 for the compensation column. So now we will try to check what is the data that is displaying in com. When the version is 0, it is showing as null, and when the version is 1, what it is going to display? It is going to display 0 in the case of null. Okay, okay, see, it is going to display 0. So that's how in the delta format we can do, we can perform, we can create tables, we can perform, and we can actually check the data, how the data is stored. So if you could see over here, I think I didn't remove that, that's the reason it is showing a 0. So now once the tables are created, once this is performed, we can do a lot of other things. We can let's say, if at all, if you are let's say I am storing the data and partition by department number, we will have different files that will be created for each department. Let's say we have a department called department 1020. So we will have a files that is created for 10, Okay, and we'll have a file that is created for 20, and we'll have another file that is created for 30. So each distinct. If the value, if we have 40 also, it will, I think if at all if I say 40, it will throw an error. It should throw an error. We can check that as well. No file exists. So that's how it is, right? So that's the thing. So now, so if at all if you want to check the delta log of the EMP delta, again we have three versions now. Actually, if you could see, version 0 I have updated twice. That's the reason we have three versions. So after every so let's after every 1 month, it will create, it will actually move all the files data, all the delta log data into one file, and that's how it stores. So if at all if you want to create a new database in the delta lake, then here is what you are supposed to do. If there is a database already existing, the tables already exist in the database will not get deleted. That's the reason you need to use Cascade, and then remove the database, drop the database using Cascade, and then create a new one if not exists. Okay, now the database is created, creating Parquet file format and table in the database. So we can actually create a Parquet file format in the Delta database also, and you can interchange the database types from Parquet to Delta and Delta to Parquet. That's what it is trying to show over here. So after 10 transactions, the Parquet file will be created for 10 JSON files. So every time, like if there are 10 transactions happen, 10 Parquet files. If there are 20 transactions happen, 20 log files will be created. So if it's all depends on how many transactions that you perform, and that's how it's gonna work. Okay. And here is what I'm doing. I'm mounting a directory, and I'm using the directory over here. Let me talk about other things in the next video. Stay tuned and bye for now. See.